Hello, everyone, and welcome to another episode of Clay Loves Logic. On this channel, I solve logic-based Sudoku puzzles I find interesting. Sorry for the delay in content. I was in Nashville for work, like I had said, and I tried to, put some time aside to film some videos and get some videos recorded ahead of time, but I got way too busy. So, anyways, with that in mind, let's not delay getting a video out today. Today, I'm going to be looking at the puzzle 3 and 5 by Hiyoureaders. As always, I'll put the link to this puzzle in the description of the video so you can try it out if you'd like. But with that said, let's turn our attention to the rules. Standard Sudoku rules apply. You have to have the digits 1 to 5 in every 3x3 box, in every row, and every column. We have a killer cage rule, so digits in a cage cannot repeat and must sum to the value shown in the upper left corner. These 4 sum to 10, these 3 sum to 10, etc. XV dominoes, cells separated by an X sum to 10, cells separated by a V sum to 5. There's no negative constraint. And actually, there's no V's. That's not even in the rules. Sorry. Kropke pairs, digits separated by a black dot are in a 2-to-1 ratio. If this is 2, this is 4. And digits separated by a white dot are consecutive. 1, 2, 2, 3, anything of the sort. Excuse me. Sorry, we have quadruples. So digits in a quadruple circle must be placed in at least one of the 4 cells surrounding that. So here we'll see we have alternating. We'll have a 2, 2, and a 3, 3. Same here, a 5, 5, a 6, 6 in some order. And skyscraper rules. So a clue outside the grid gives the number of digits that could be seen from that clue's perspective in its row or column. Higher digits obstruct the view. Lower digits placed anywhere behind the digit do not contribute to the skyscraper rule in that direction, i.e., if we look at this 3 is from this perspective, right? It looks that way. So if we put a 9 here, that's wrong, because this 9 will block all of these other digits from view. There's nothing higher than 9. Think of it as floors of a building, right? So if you're looking directly ahead of yourself and you see a building that's 9 stories tall, if the next building behind it is 8 stories tall, you won't see it. You won't see the 7 or the 6 or any of those other digits. If this is a 1, however, you're looking out across the street at a single-story house. And behind it, you can see a 3-story house. You can see that 3-story house. If this is a 2, there's a 2-story house that's there, but you wouldn't see it. If this was a 6, you would see that. And at this point, that would be valid. This would be 3 in the row. All of these would have to be lower than the 6, which obviously doesn't work, but you can see how that actually does happen and how that works. So those are the rules for the puzzle. Let us turn our attention to the puzzle itself. First thing I can tell you, if you look at a 5-cell, if you look at a 4-cell 10 cage, it just has to be 1, 2, 3, and 4. So all of these digits have to be higher. They all have to be 5, 6, 7, 8, and 9. I can also tell you that one of these digits here will be low. 1, 2, 3, or 4. So these 3 digits will all be high. I don't know what that says about the puzzle yet. I don't even think that's the place to start, but likely the place to start is, this center intersection here, because if we look at the puzzle here, we have a skyscraper that looks out this way, skyscraper that looks this way, a skyscraper that looks down, and a skyscraper that looks up. All of those clues are 3, and they all point to the middle here. So what that says is, well, what's the biggest digit this can be? Well, it's only a 2 or a 4, isn't it? Because this is a 3-cell Kropke, is how I like to think of it. So it has to be adjacent, it has to be a middling digit, because if this is a 1, we'd have double 2s. If this is a 8, we'd have double 4s. This can only be a 2 or 4, and it can be flanked by 1, 2, 4, and 8. So how does this look with this 3 clue? What it's saying is this 3. So we'll see 3 digits of escalating height somewhere. And we'll see 3 digits of escalating height somewhere. So no matter where the 9 is, for example, these 3 clues will both see the 9 as their tallest digit. So I think that means this is a 9, because we can force this to be 4 and 2 or 2 and 1, and it can be small. But if this is a 9, how do we get so many? I mean, I guess we could have an 8, 2, 3, 6, 4, 9 or something. Yeah, maybe. Okay, maybe that's just rubbish. Let's look at this one because we know all 4 of the digits, don't we? We have a 3, a 4, a 5, and a 6. 2 of these are in the cage. So if we minimize them, we say we have a 3 and a 4. That would require this to be a 3, which doesn't work. What else can we do? 3 and 5 is 8. That would require a 2. That's valid. 3 and 6 is 9. That would require 1. 4 and 5 is 9. That would require 1. 4 and 6 doesn't work. 6 and 3 is 9. Okay, so this is always a 1 or a 2. This is always a low digit, which means it's always going to be one of the 3 skyscraper clues. Because, you know, if this is a 2, the lowest digit this can be is a 1. And actually, if this is a 2, this is an 8, isn't it? It is. That's true. Well, you know what the other point I had to make was one of these digits will be low, actually. That's the point. That's the takeaway. One of these digits is low. It has to be. This is a 1, 2, 3, 4 quadruple. But we need one of the digits 1, 2, 3, or 4 to sum to 10, which means these two digits can't be from 3 or 4. They're all spoken for. So this is a 5, 6 pair, which means this is a 3, 4 pair. Now how does that work? 5, 4, 1, 5, 3, 2. Okay, so this is still all correct. But now 5 and 6 are spoken for. What that means is 6, there's always a 4 in this now. This is not a 4. And I say that because 6 and 4 pair to 10. They can't exist here, but there is a low digit here. So this is now a 1, 2, 3, 7, 8, 9, something of that sort. Okay. Let's continue thinking about what we know. And I'll preface this by saying I'm truly not very good at these skyscraper puzzles, so bear with me. Well, you know what I can tell you, and here's the first real takeaway, and we're about to get a digit, is when you look at this double 2 and double 3, it means they alternate, i.e. both of these are 2 or both of these are 2. And I'm about to tell you right now that both of these are 2 with confidence. Because if both of these were 2, you couldn't put a 2 in here, and you have to. This is either 1, 2, 4, or it's 2, 4, 8. But there's no other way it works. Both of these are 2, both of these are 3. That gives us an 8 here. And now an 8 there removes this as an 8. This is a 2. But more importantly, this is now never a 4. Or no, sorry, it could still be a 4. It could be 4, 2, 1. 1, 2, 4, 4, 2, 1. We have a 1, 2, 4 triple now. All right. Oh, and the next part is there's not a 4, or there's always a 4 on this, so one of these is the 4. And it's not this one because we have a 3, 4 pair here. So there's a 4 somewhere here. So there's no 4 in this row. Well, I mean, yeah, we know that. There's always a 4 on this. There just always is. Now, what is the takeaway with this double 5s and double 6s? If this is double 6, this consecutive digit could be a, well, okay, that's interesting. Let's think about that for a second. If this is double 5, and that doesn't work, does it? Oh, that's really nice. think about it. If that's the first setup, well, this is double five and this is double six. Well, if this is double five, this is either 4 or 6, and it can't be either because we have a 3-4 pair here. So this is in fact double 6. This is double 5, and better yet, it gives us a 7. I wish that it would resolve this, but that's okay. So the next little morsel, what do we get next? Well, 6, 7 is there. 5 could still be most places. Yeah. And then 9 could also be most places. So maybe that's not interesting yet. Okay. So what should we consider? Well, if we know 4 is always here, 4 is in one of 2 positions here. So still lots of options. Maybe we need to consider this, how this 1, 2, 4 triple works, because no matter what now, unless this is a 9, the 8 is we will see this 8 in this skyscraper. And if this is a 9, then we'll see the 9, which will always be one of those 3 digits that we see. We can only have 3 increasingly tall digits. So this is the first one. The biggest this can be is a 2. Let me think about this for a second. We'll see a 2. That's one of the 3. This would have to be smaller than the 2 for it not to count. For it to be smaller than the 2, it's a 1. And then this is broken. Doesn't work. Because both 2 and 1 are spoken for. So in fact, whether this is a 1 or a 2, it doesn't matter. This will be a taller digit, won't it? So it needs to be a really tall digit to not be affected by these. It needs to be at least a 5. It can't be a 6 or a 7. It can't be an 8, and it can't be a 9. Whoa, is this a 5? Is this a 5? I think this is a 5. Let me think about that for a second. This is a 1 or a 2. We can't put a lower digit than 1 or 2 here because we have a 1, 2, 4 triple. So then we can't put 3 in here because we have a 3, 4 triple here. We could put a 5. We can't put a 6 or 7 or an 8. And if we put a 9, we can't have a higher digit. This is a 5. Whoa, that's cool. So this is a 6, and this is a 5. And that's just actually true. And now, what are we learning? If this is a 9, that would be fine. Because then we would have 2, 5, 9, and this would end. And then on this side, we could have any low digit here, like a 3, and it could be 3, 8, and it wouldn't see anything else until the 9. Or 9 could be here. But then we can't have any digits taller than a 5. Yeah, and then actually the next question is, what do you even put? What do you put here? You can't put a 1, 2, 3, 4, 5, 6, 7, or 8. This is a 9. Oh, that's so interesting. So then somewhere over here, you need another digit that's, well, what else do we need here now? 1, 2, and 8. And this can't be a 2. So this is 1 or 8. And then this is 1, 2, or 8. That's something. Okay. So now, well, what are our options for, what are our options? We should be able to figure this out now with this clue. 1, 2, 4. We'll need a 3 somewhere that's not here. We'll need 1, 2, 4, 5, 6, and 7. So that's actually really, really nice because this is a clue of 3. So if this is a 3, then it's wrong because it'll see the 3, it'll see a digit that's higher, a digit that's higher, and it'll a digit that's higher. If this is a 6, same thing. Well, let's think. First of all, this is not a 3. So the question is now, could this be a 6? 6, 3, 8, 7, 9. Yes, it could. But actually, we have a 6, 7 pair now. So this is a 3. Now it doesn't matter what goes where as far as our problems concerned, as far as this sand or skyscraper is concerned. Whether this is a 6 or a 7, it makes no impact on the puzzle because it will always see the 8 and then the 9. It will never see this digit no matter what. It's always going to hide behind the 8, so we're fine. And that constraint works. We'll need a 3 somewhere up here, not here, and not here. That's interesting. Look at that. We need a 3 somewhere up here because of these 3s. This can't be a 3 because we have a 1, 2, 4 quadruple. And if this was a 3, we'd have to put a 6 here because of this 2 to 1 dot, and we have a 6 there. So this is not a 3. That gives us a 6 and a 3, which gives us a 7, which gives us a 6. This is a fun puzzle. So what combination of digits do we need, or where should we turn our attention to next? Well, this can never be a 2, can it? Because this can't be an 8 anymore. The only way this could be a 2 is if this was 2, 4, 8. I could have seen that earlier too. So what it means is there's always a 1 here. Or sorry, there's always a 2 here. That tells us this can't be a 2. This is a 1. And now 5 plus 1 is 6. So that requires this to be a 4, this to be a 3. This is an 8 via Sudoku. And this is therefore a 2. So now this can't be an 8. So, because we can't have a digit bigger than, that hurts, miss. I'm going to put this away for now. Because we can't have a digit bigger than an 8, or bigger than a 4, the central digit could never be a 4. This central digit now is always a 2. And we have a 1, 4 pair. Oh, and this is a 1. So we have a 4. 4, 2, 1. Now, what is that telling us? Pick up the baby. Get a toy for the baby. Sorry, I'm trying to solve this puzzle. Ellie, I'm trying to solve a puzzle, miss. 1, 2, 3, 4, 5, and 6. We have a 7, 8, 9 here, don't we? And then this is going to be from 1, 5, 6. This is not the 6. Okay. So what do we do with that information, honestly? Well, let's do a little Sudoku. Let's clear out this can't be a 3 anymore. This can't be a 2. This can't be a 1. This can't be a 4 either. So this is starting to be a little restricted because, you know, the capacity for this to be a low digit is 2 or 3. And if this is a 2, this would require this to be an 8. If this is a 3, this would be a 7. So this actually can't be a 3. And then if this is the low digit, what could it be? Well, it could actually be 1, 2, 4. If it's 1, we have to put a 9 here, which is fine. If it's 2, we need to put an 8, which we can't do. If it's 4, we need to put a 6, which we can't do. So this is limited now to either 1, 9 or 2, 8. All right. So let's continue to consider skyscrapers because right now we can see 2. And actually, the next thing is we need to put 8 and 9 somewhere. Scared me. Hey, miss, come on. Play with your toy. We need to put 8 and 9 somewhere in this skyscraper, don't we? We do. And this can't be 8 or 9, because if this is 8 or 9, we can't fulfill this. If this is 8, there's not 5 digits higher. And if it's 9, there's obviously not 5 digits higher. This is a 5. It's the only thing it can be, because it can't be a low digit. 1, 2, 3, and 4 are all spoken for. So this is a 5, which makes this a 1. We remove 1 from there. And now, well, we have 5, 6, and 7, which are 3 of the 5 skyscrapers. So somewhere along the way, we're going to see an 8, which is the next one. And then the 9 is going to have to come after it. So the 8 has to be here or here. It can't be here because of the 8 already. 8's can either be here or here, and then 9 will be there or there. Oh, that's beautiful. This can't be a 9, so we have a 5 clue. Wow, this puzzle really starts to get moving. So this has to be a 9. This has to be an 8. And now, what's this combination of digits? 1, 2, 3, 4, and 9, which resolves. 4 and 9. And then what's this? A 2. It's the only thing that's left. This is a great puzzle. Wow. I'm really, really enjoying this puzzle. This digit now. We need a clue of 3. Well, this digit can't be 1, 2, 3, 4, or 5. So what's its options? 6 or 7. If it's a 6, we could have 7, 8, 9, or something like that. But it can't be anything higher than that. It just can't be. And in fact, Sudoku would tell us that this is always a 6, because none of those are 6s, none of these are 6s, and none of these, 6, 6, 6. We have 4 6s looking at it, so that's a 6. So this digit now can't be, could this be a 7 still? Well, actually, 6, I don't know. I don't know. I have to think about that. What I do know is these 3 digits are now from 7, 8, 9, and Sudoku says that's not a 9, that's not an 8. Okay, let's think about this clue now. Oh. I don't have a tremendous amount of time to solve this, but that's okay. I'm gonna give this. I should resolve it pretty quickly here. This is a fun puzzle. We're gonna need what kind of digits? I'm not sure. I'm sure there's an easier way to think about this. Well, actually, the question still remains, where does the 1 go? Can't be here or here. So one of these is the 1. And this is not the 1, because if this was a 1, this would have to be a 2. Forgot about that 1 clue. That's nice. So that helps us out a bit. That's a 1. So that's a 4. This now has to be 5, because there's already a 3 spoken for. Oh, that's great. So what does that tell us now? 5 and 4 are now moot. Or actually, sorry, we don't have a sandwich clue there. Or a skyscraper clue. I thought we had a skyscraper clue. Disregard. We have a 5 somewhere over here. 1, 2. 1, 2, 3. In fact, we also have a 4 somewhere over here. 4, 5, 6, 7, 8, 9. 4, 5, 7, 8, 9, and 3. But the 3 is less interesting so far. Okay, we've satisfied the 1, 4 clue. The 2s, 3s, that's all good. That's all good. Still can't do that one yet, surprisingly. I feel like we just need to oh, you know what? Yeah, of course we can. If we consider this skyscraper clue of length 5, which it needs to see 5 digits get higher. So it'll always see 6. It'll see whatever the first one is. That's 1, that's 2. How could we, 2, 1, 3, 4, 6. No, that's not going to work. 2, 4, that's 2. I'm not sure yet. I'm just not quite sure yet, but let's think a little bit more. We need a 4 somewhere in this. I'm going to look at this first box for a minute. 4 somewhere over there. We need a 2 somewhere, and the 2's not down here. So the 2's in one of two positions. That's true. Can we ever get a 2? Yeah. Yeah. Okay. Well, better question is where do we put a 9 in this box now? Not in the top row, not in here. And yeah, just one spot. So a 9 and a 1. And that's now a 1. So this is a 2, 3, 4. So this is what, 7 and 8. Doesn't resolve yet, but that's okay. So the 1 will never be seen. The 5 will never be seen. We'll always see this 6. We'll always see at least the first digit. And we'll always see at least this. Those are the 3 that we'll always see. But we need to see exactly 2 more. How many 9s see this box now? 9, 9, 9. We can place a 9, can't we? 9 can't be there. And 9 can't be there. This is actually a 9. Okay, so now we're going to see these 3 guaranteed. Maybe I don't even need to be putting this much thought into it just yet. 9s, 9s, 9s. 9 is in one of two positions. I'm just looking at, some of the digits we have and thinking about what can go where. Yeah, so what if this... I'm really trying to just spend a little time. Well, you know what? Why actually, better yet, why don't we consider this? Why don't we consider this bottom row? Because I hadn't really thought about this 5 clue looking this way, or this 5 clue, to be honest. I kind of forgot about them. But a 5 clue is pretty substantial because, quite frankly, it'll see the 8, it'll see the 9. And then we need to have 3 other digits, but they have to increase in value to get there, don't they? Because it'll see the 9 and 8 always, and it needs to see 3 more, and it can't see any of these, and it can't see this. These have to be in increasing values. So what are our options? That's going to resolve this in a really nice way. We need 2, 3, and 6. So this can't be a 2 via that 2. Oh. Oh, wait. 2, 3, and 7. Okay. So that's going to make this 3, 6, 7, and this 2, isn't it? If this can't be a 2, it needs to be the next smallest digit. So 3, 6, 7, 3 in the corner, 2, 3, 4. That's just going to do worlds. So we see 3, 6, 7, 8, and 9. Over here, we see 2, 4, 6, and 9. So this is now, it doesn't matter what the digits are. We're going to satisfy that just fine. And that gives us a whole bunch of stuff to work with, I'm sure. Because we should be able to place basically almost everything now, I think. 6 in one of two positions. And 2, 6, 7, 8, 9. Okay, that's possible. Okay, maybe 6 isn't the most interesting yet. What about 1s? 1 is interesting. Look at that. Where do you put a 1 in this box? Okay. A first glance, 3 positions. But where do you put a 1 in this row? Well, you don't put it here because of this one. You don't put it here because of this one. This is a 1. And then where now? We could put a 2 in a couple places. Okay. Next. So actually, what do we actually need in the central in this box? We need a 2, a 3, 7, 8, and 9. And then none of these are 9. Neither of these are 2. Neither of these are 3. That's it. Okay, this 3 clue. Well, first of all, let's think about this actually. There's only 2 digits we need here. We just need 4 and 9. And isn't that just actually 1, 2, 3? Yeah, it's just 4 and 9. And this can't be a 4. So this is a 9. This is a 4. Neither of these are 4 anymore. And that is going to do what? I don't know yet. Well, it's going to place a 9 somewhere over here. And it can't be this, obviously, because we couldn't have anything higher. So 3, 5, 7, 8, 9. Maybe we actually do have to start considering this because we need to put a 3, 5, 7, 8, 9. 3, 5, 7, 8, 9. 5. This is not 3. This is not 9. This is not 8. Could this be 7? 7, 8, 9. No. For this to be 7, well, let me think. 7, 9, 8. Barely. 7. No, it couldn't be a 7, could it? If this is a 7, we need to get to 7 digits that are higher. If this is a 7, this would have to be 8. This would have to be 9. Yeah, no, it doesn't work for this. These two clues fight with each other too much for that to work. That has to be a 5. And now we've seen the 5. We need to see 2 digits higher in this direction, and we need to see 2 digits higher than the 6. So they're both going to share the 9, won't they? That removes this ability to be a 9. Yeah, so 9 is in one of 2. Well, yeah, 9 is in one of 2 positions. If this is the 9, this would have to be 8, and this could be 7. And yeah, that works. Okay, sure. So, well, what we know, actually, what do we now know? I don't know what we know yet. Let's think. Let's keep thinking. What kind of digits do we need over here? We need a 1 and a 4, which is not resolved. Down here, we need an 8 and a 9, which is, no, ooh, almost messed up. This 9's in a silly place. What, 2 and an 8, unresolved. Are these 4 digits? A 4 somewhere, a 5 somewhere, 6 in one of 2 places, and a 7. Again, if this is a 7, 8, 9, that's only 4. That's not enough. If this is 6, 7, 8, 9, that would give us 2, 6, 7, 8, 9. That would give us 5 digits, which would almost be fine. But this is a 2 actually, so this is an 8. This is a 2. And now 8 won't count as one of the high digits. So 9 will be the high digit, and then it has to be here, doesn't it? Yeah, because if this is 9, we don't have enough latitude to get to tall digits. Yeah, that's all true. So none of these are 9 anymore. This is from 3, 7, or 8. We need a 1 somewhere over here. 2, 3, 4, 5, 6, 7, 8. 7, 8, 9, and 1. None of them are 9. So it's 1, 7, or 8. And this is not 8. And it's not 1, is it? Because I think all these have to just be increasing in value to get to this. I think this is 4, 5, 6, or 5, 6, 7. Or sorry, I think this is 5, 6, 7, right? 2, 5, 6, 7, 9. Oh, none of these are 5. 4, 6, 7. Yeah. 2, 4, 6, 7, 9. Yeah, this is a 1. This is a 4. This is 4, 6, 7, 9. This is a 5, 7 pair now. This is no longer 7. So this is a 1 because that's a 3, 8 pair. Yeah, this is a 2, 7, 8, 9. 2, 7, or 8. Oh, this is an 8 by a Sudoku of all things. That's a 7. This is 9. Neither of these are 8 anymore, and this is not 9. Okay. So this is 9, and then this is 7. That's the only way to get that constraint. This is 8. This is 3, and that satisfies that constraint. This is 8. That makes this 7. This is 3, and this is 2. This is 8. This is 7. This is going to be 8. This is now just 4. This is 2. This is going to be 5, 6, 7, and 5. 36 minutes, 1 second. 117 people have solved this puzzle in 9.6 days. I did like this puzzle. Very fun puzzle. Hiyoureaders 3 and 5. I liked it. I hope everyone enjoyed, and I hope you tune in on the next one. Thanks.